Alright, let's scare you with some limits. Okay, for limits like these, we are doing multiple operations or steps. It's always very helpful to separate them out, split them out. And I can do that by kind of distributing. We're not really distributing, but we can write them individually. The limit as x approaches 3 from the right of x squared. Now notice we're going from the right, not for the x squared of the 3, but really for our rational part here. Plus the limit as x approaches 3 from the right of 3, plus the limit as x approaches 3 from the right of our rational function here. Now, for the 3 to the right of this one, doesn't matter. If I can just substitute that in, I get 3 squared plus, this is our constant rule, it just stays 3 plus, now here's our problem, it's our rational. We graph rationals. Here's x equals 3, here's my vertical and horizontal asymptote. I pick a point, 0, that's negative 1/3, so right over here, no multiplicity. There we go. And as we approach 3 from the right, it's going to positive infinity. So let me ask you a question. Does it matter what all these are? 9 plus 3 plus infinity? That's still just going to be positive infinity in this case. Kind of a fun problem right there. Okay, let's take a look at number 9. Now notice this has this x cubed, and then it has our, if you notice, take a look here, it's our weird absolute value function. So I'm going to write this as like multiplication. The limit as x approaches 2 from the left of x cubed times the limit as x approaches 2 from the left of the absolute value of x minus 2 over x minus 2. Well, for the first one, we can just substitute in. We get 2 cubed. The second one, I'm going to sketch it. 2 is where my special's at. Remember, it's either going to be 1 or negative 1, and they're both wholes. There's our graph, just like we did yesterday. And remember, we're approaching from the left this time. So as I approach from the left, as 2 from the left, we're on the line negative 1. So there we go. Now 2 cubed we know is 8. 8 times negative 1, negative 8. And there's our limit right there. Very easy to do. Make sure your negative sign is pretty easy to see. All right, let's try number 10 here. Okay, we're approaching 0 from the left. So again, I'm just going to separate this all out. From the right this time. The limit as x approaches 0 from the right, sine of x over x, times the limit as x approaches 0 from the right of 1 over x. Now this is our rule from today. We should know this one. That's just 1 times, here's our rational, graph it, there's our horizontal vertical, and it goes a little something like this. There it goes. That's what rational functions look like. And as we approach from the right, it looks like we're going to positive infinity. So what's our answer? Positive infinity. There we go. Alright, so real quickly on your own, see if you can try number 11, and we'll go over that one tomorrow in class. And that's it. I really enjoyed working with you guys on the flipped classroom. I hope you guys learned something. And don't forget, next year when you take calculus, all these notes will still be online. Help you. Bye.